Hey class, today we're going to be working through a problem that I have for you, and I've put that in an audio ebook format so you can follow along with a pencil and paper at home while we listen to this story and work through it together. So, let's say that you're an astronomer and one night you notice a tiny speck in the night sky through your telescope. So you decide that you want to try to figure out what that speck is and you want to learn about it. Maybe it could be a new planet, maybe you could name it after yourself, because that's the ultimate goal of an astronomer. Anyways, you observe it over the next 5 years and you notice that it takes that entire time period to return to the same relative position after 5 years of observation. So, you're going to use your knowledge of physics to see what you can learn about your new planet just by knowing that it takes 5 years to travel one time around the sun. Let's go to the chalkboard. We know that a year is the period of a planet's orbit around the sun, and we know that that means our new planet has a period of 5 Earth years. So if we want to know how far this planet is from the sun, we can use Kepler's third law. So, Kepler's third law states that the period of a planet squared divided by its distance to whatever it's orbiting cubed is equal to 4 times pi squared divided by the universal gravitational constant times the mass of the sun or the mass of the thing it is orbiting. Okay, that's a useful tool, but this is a lot of numbers and math over here that I really don't want to do. And I see squareds and I see cubes, so this probably won't be very fun. But it turns out this equation is actually very, very simple to use. So, what do we notice about 4 pi, g, and the mass of the sun? Every single one of these things is a constant. 4 is a constant, pi is a constant, the universal gravitational constant is a constant, the mass of the sun stays pretty constant. So we can actually put three or two equal signs here, and we can put in what we know. We know the period of the Earth, we know the distance from the Earth to the sun, and we know the period of our new planet, and we want to know the distance from the sun to our new planet. So, just to explain what this is one atomic unit, which we define as the distance between the Earth and the sun. So, the Earth and the sun is one atomic unit apart, one Earth-Sun distance apart. So, since we have these two things both equaling this constant, it follows that these two things equal each other. And 1 squared divided by 1 cubed is just 1. So this actually boils down to a very simple equation. 1 is equal to 5 years squared over this distance cubed. So we can multiply this term to the other side. We can take the cube root of both sides, and we can see that this planet is about 2.92 astronomical units from the sun. So, go ahead and work out on your own, using the fun fact on the last slide, how far this planet is from the sun in meters.